Prove the following equation has exactly two solutions. You have e to the x minus square root of 2 times x equals 5. So for this, we'll let f of x equal this equation, but we need to subtract the 5. And basically, we want to see when this is equal to 0, right? Because if you subtract 5 here, you want to see when this equation equals 0. So for this, we want to take the derivative. The derivative of e to the x is e to the x. Negative root 2x is just negative root 2. And we're going to set this equal to 0. And so add the root 2 and take the natural log of both sides to get that x is equal to natural log of 2, root 2. Which, if you want, you can say that's ln of 2 to the 1/2, which is just 1/2 ln of 2. So that's going to be our critical point. And so we want to see what happens to the left and right of it. First thing to note is that the domain of this function is all real numbers. So that's good. And so if we pick x to be really big, you have e to a really big number minus root 2 times a big number minus 5. E to the x is going to be more dominant. So this is going to be positive. It's going to go to positive infinity. And if we pick a number that is less than 1/2 ln of 2, let's say 0, you plug it in here, and this is going to be negative. So it's going to be decreasing. So from the left, it's decreasing. From the right, it's increasing. And if we look at f of x, if we take the limit as x approaches infinity, positive infinity, like we said, e to the x minus root 2x minus 5. E to the x is more dominant, so that's going to go to positive infinity. But then if we look at x going to negative infinity, e to the x is going to go to 0. This is going to go to positive infinity because we have negative root 2 times negative infinity, which is just positive infinity. And then minus 5, that's still going to positive infinity. So if we were to graph this, just to get an idea, we know the endpoints are here, and then 1/2 ln of 2, that's somewhere here. So if we kind of want to get an idea of where that value is, instead what I'm going to rewrite it as ln of root 2. So if I plug it into f of x, we have f of ln of root 2. That's e to ln of root 2 minus root 2 times ln root 2. And then minus 5. E to natural log root 2, the e to the natural log cancel. We have root 2 minus root 2 times ln of root 2 minus 5. We have root 2, factor that out, we have 1 minus 1/2 ln of 2 minus 5. We know that ln of ln of 1 is 0. Ln of 2, it has to be bigger than 1. And so 1/2. So basically, this thing right here, using a calculator, will be less than 0. And so that will say somewhere down here. That's going to be our local minimum. And so what's happening is our graph is going to come in like this. Something like that. We don't exactly know where it's going to hit the x-axis, but we know by the intermediate value theorem that 0 is going to be one of the values it hits on the left here because it's continuous, and basically you need to connect this. So if you connect this, it's going to have to cross 0 over here, and then it's going to positive infinity, so we're negative here, it's continuous, so it needs to hit the x-axis again. And so we say that we have exactly two solutions.